Hello, my name is Oliver Benton, and today I'm presenting my project on how predictable summit success is across different Himalayan peaks. I'll explain the data I used, the machine learning methods applied, and the key differences we observe between mountains. This project was inspired by my trek to Everest Base Camp, where I learned a lot about the climbing process, and it made me wonder, why do some peaks seem more predictable to summit than others? The central research question became, how does the predictability of summit success vary across the top 10 most summited Himalayan peaks, and what drives those differences? This matters because improved understanding of summit predictability can support safety, risk planning, and expedition decision making. If certain peaks allow more reliable predictions, climbers and guides can make better informed choices. The dataset comes from the Himalayan Expedition dataset on Kaggle. I primarily used the members.csv file, which contained detailed climber level data. I merged this with peaks.csv to include peak height and names. Key features that we used included demographics such as age and sex, experience-related variables like hired support, Sherpa assistance, and oxygen use, route information in the season, a crowding metric I engineered by counting climbers per peak per year, plus new engineered features like age at climb, age squared, and a Sherpa and oxygen interaction term. This gave a rich set of climber and expedition characteristics to model. I began by cleaning and preparing the data. Missing values were removed, and I stratified the train test split to preserve the success/failure balance. Because summit success is relatively rare, I used class weight equal balance to help the model pay proper attention to both classes. The core modeling technique was logistic regression, which predicts the probability of a successful summit. The choice fits well because several relationships, most notably age, show clear monotonic trends with summit success. To reduce dangerous false positives, as people can die with these, I also tuned the decision threshold. A model incorrectly predicting success is a lot more riskier than incorrectly predicting failure, so I shifted the threshold to improve precision. Finally, I built separate logistic regression models for each of the top 10 peaks, using identical hyperparameters, and repeated each experiment across 5 random seeds to check stability of the models. When comparing results across peaks, clear patterns emerged. Everest and Lhotse consistently produced their highest recall and precision. This makes sense. Both peaks share the same exact route up to Camp 3 and are highly commercialized and have well-established climbing patterns. Annapurna 1, on the other hand, had the highest specificity, meaning the model was particularly good at identifying failed summits. This aligns with Annapurna's extremely high mortality rate and unpredictable conditions. Success is rare and difficult to model. Other peaks like Amadablam, Cho Oyo, and Himlong Himal showed much lower recall, meaning the model struggled to identify climbers who would succeed. This hints at missing variables, for example, weather, technical difficulty, and team-related factors that aren't in this dataset. To formally test whether these performance differences were statistically significant, I ran a one-way ANOVA on the mean recall, precision, and specificity across every peak. All 3 metrics were significantly different at the 5% level. Recall by far showed the biggest F-stat, followed by precision and then specificity. This confirms that each peak has its own unique predictability profile, and that modeling climate success works very differently depending on the mountain. Bringing this all together, the results show a strong link between route consistency, commercialization, and predictability. Well-established and frequently climbed peaks give the model a far more stable signal to learn from. In contrast, peaks with higher objective risk, inconsistent conditions, or lower climbing volumes create noisier, harder to predict outcomes. This can suggest that climber characteristics alone cannot fully capture the complexity of summit success on more dangerous or technically complex mountains. In conclusion, summit predictability varies substantially across the Himalayas. Everest and Lhotse are relatively predictable, while peaks like Annapurna 1 remain highly unpredictable. For future work, incorporating weather data, team logistics, and perhaps non-linear machine learning models could help improve prediction accuracy. These would better capture the multidimensional nature of high-altitude climbing. Thank you for listening.